Perfect, perfect. So let's get started. What are the problems we have on our plate today? Let's see. So last day, if you remember, we did a really interesting problem about, symmetry of random variables. So I hope you remember that, guys. The symmetry of random variables problem we did. So let's revise the idea of symmetry of random variables. Guys, do you remember that problem, symmetry of random variables? Any doubts in that problem? So did you understand the main idea? The main idea revolves around the fact that probability, like if x1, x2, x3 are IIDs, so any random variable, okay, if x1, x2, x3 are any random variable IID, x1, x2, that are IID random variables, okay? So the question was about symmetry of random variable. What we did is this, that we told that probability any xi x1 less than any xi1 less than any xi2 less than any xi3 करते करते less than any xin is 1 by n factorial. Okay, why? Because each of the individual permutation are equally likely, and we have shown that by example. And this is a really interesting idea and interesting property which is really important for your understanding of the subject. Okay, so let's do some problems again based on this, because this idea will be useful for the examination purpose and understanding purpose over and over again in your like preparation stage and final examination. Okay, so let's get started. So what problems do I have on my plate today? So this is one of the problems. Let's do it. But I'm not assuring it from this idea, but let's see. So problems are that x1, x2, that are IID normal random variables, okay? The IID normal 0, 4 random variables, and J with the smallest value of, so J is another random variable, okay? So what is J? J is another random variable, which is the smallest random variable. Smallest, such that for the first time, xj is greater than j. Xj is greater than 4 for the first time. My handwriting is becoming so bad day by day. Just give me a minute. Smallest j such that xj is greater than 4 for the first time. Okay, so this is a basic problem. So what's asking you is asking you to find expectation of j in terms of phi. Phi is what? Phi is the standard normal variable ka CDF. In the next Monday class, I will share with you how this normal random variable comes, but today I will share with you like how the what is the how can we do this problem. So any ideas, guys? How can we do this problem? Any ideas on how can we approach this problem? Yeah. Any ideas? Nikhil, Abhirup, Mansi, Mayur, Paulami, Pratik, Pratiksha, Proma, Sritej, and Shuprabhu. How to approach this problem, guys? How to approach this problem? What do you think? No ideas? Hello, can you hear me, guys? Yeah. So, any ideas? Yeah. या बोलो. Okay, so define indicator random variable I j if which is equal to 1 if xj is greater than 4 and 0 otherwise. That's a nice one. So I will tell you one student was asking me that they when to use indicator random variables. So indicator random variable is really used to count stuff. So how to count stuff, guys? How to count stuff. So you use to use indicator random variable because counting, as you know, comes from. Like I think a Birup was only asking that day, or maybe Shuprova, anyone was asking about the counting. Like actually, indicator random variable is done exactly like that way, like how to count stuff. Okay, so like because indicator random variable is a Bernoulli random variable, and Bernoulli random variable is counts number of successes. Okay, so let's get started. So it's easy. So perfect. So can you just the right step, Nikhil? Can you just do the next step? The right step, Nikhil. We told that to find out to apply what? To apply the idea of indicator random variables because we are counting with which index is like getting x4 x greater than 4. So what is the distribution of ij? What is the distribution of ij? Nikhil, you're in right direction. Bernoulli what? Bernoulli? P is half. P is half. Xj follows normal 0, comma 4. So probability xj greater than 4. Like what is indicator random variable? So it must follow P. P is equal to what? Probability of A. This is the set A. That is probability of xj greater than 4. So what is this probability xj greater than 4? So we have to find in terms of what? Phi. Can you write it in terms of phi? Perfect. So 1 minus phi 4. So ij follows Bernoulli 1 minus capital phi of 4. All of you understood till this point of time? All of you understood this? Yeah. There's a no, it's not 1 minus phi of 4. You're wrong. I mean, it's not correct. Yeah, yeah. Thank you for reminding me. I mean, for telling me. Yes, it's not 1 minus phi by 4. Yes, because x like xj follows normal 0, comma 4, right? So to find probability xj greater than 4. It's not 1. Yeah, you're right. Thank you. So what will happen is that probability xj by 2 कर लो. So it will happen greater than 1, right? So what we want to find? We want to find xj, like we want to find some standard normal distribution, right? So this is standard normal, xj by 2 is standard normal distribution. So what we'll get? Probability Z greater than 1. So now essentially it's 1 minus probability Z less than equal to 1. So what we get? It's 1 minus phi of 1. Did you get it now? Did you get it now? Yeah. Sorry for the previous mistake. Follow me, you should be much more careful on this. Don't make this mistakes, simple mistakes in the exam hall. Okay, so this is the idea. So what we get? We get that ij therefore follows Bernoulli 1 minus phi of 1. All of you understood this? Write a boom in the comments. All of you understood this clearly? Perfect. Okay, superb. So now, thank you, Shika Sharma. So now understand that this problem is now therefore based on what? This problem is therefore based on what we are looking for. Can you just explain the problem now? So we want to count what? We want to get the first success when? Can you just tell me now? It's very easy now. Nikhil has perfectly formed the problem. Now it's very easy. Nikhil. So what is J? What is capital J? Can you tell me? What is capital J now? It's very easy. Capital J is capital J follows capital J follows geometric. Perfect. So it's a Bernoulli process, right? It's a Bernoulli process. Ij like I1, I2, I3, that this follows a Bernoulli process. Like what is a Bernoulli process? It's a sequence of Bernoulli random variables, IID. Now what we are looking? We're looking for the first J. For the first J, where Ij is 1. That is the first success. Number of like J number of trials before the first success. So Ij follows what? Ij, sorry, this J follows therefore what? Geometric 1 minus capital phi of 1. Right? It's very easy, guys. Did you understand? All of you. It's very easy. Did you understand, all of you? Nikhil, did you understand? Pratik, are you understanding? I wish, I hoped you could have told that you were just in the perfect right direction. Thank you, Abhiru. Perfect. So we have done. Oh, sorry. I'm so sorry. Sigma square. No, only mu comma sigma square is there. No, not mu comma sigma. Index means this. The subscript. I mean the J, x1, 1 is the index of x1, 2 is the index of x2. Like it's counting the number of steps actually, number of trials. Okay, perfect. So all of you understood that it's a geometric now, and therefore like expectation of J क्या होगा? 1 by 1 minus phi of 2. 1 by p is the probability or expectation of geometric. All of you understood this problem, guys? It's a very easy problem. Sritaja? I hope you understood that. Pratik, did you understand this? Thank you. Good. Perfect. So let's move on to the next problem. There's a big problem. So let x1, x2, and xn be the number of the annual rainfalls, not the number, sorry, the annual rainfall of the years in Boston in the years 2101, 2102 respectively. Okay, consecutive years in the 22nd century. Okay. So it's asking to assume the rainfalls are IID draws from the continuous distribution. Okay. Assume the rainfalls IID draws from the continuous distribution. A rainfall is a record high if it's greater than those in all the previous years, and record low if it's lower than all the previous years. So we have done this problem last day, right? So we'll do again this problem for the just like a last day, okay? But we will do all the other parts also. Okay. So in the 22nd century, find the expected number of years that have either a record low or a record high rainfall. So let's see how will you on this mathematically, like probabilistically model this. So in the 22nd century, find the expected number of years. So understand, find the expected number of what? Expected number of some random variable over. So what is the random variable over here? This. Okay. The number of years. Okay, number of years either have a record low or a record high rainfall. Okay. So understand what? So the idea is this. So xj is record high if it is greater than all the previous ones, that is xj greater than xj minus 1, xj minus 2, dot dot dot. Okay, x1. And xk is record low if xj is less than xj minus 1, xj minus 2, dot dot. Okay, it's a very interesting problem. So now we are considering till how many years? 100 years. Okay, so till x100 is there, we are considering. Okay, so what we are asking the number of years, either it is a record low or a record high. So understand it very carefully. So when you ask, when the general random variable is given, and when you ask about the number of something, we are out of the counting. So its number of years means you have to count here, right? Count. So what random variable will we use? What random variable will you use, guys? You're counting general random variable, so you're counting something. A given random variable is there. From there, you're counting something as a function of that random variable. So what will you use? Indicator random variable. Perfect. Indicator random variable. So when you're counting something, like the number of years used for indicator random, it's used by indicator random variable. So let's understand this. So what we will take? We will see that we'll define like this, that ij is equal to a success. When it's a success, if xj is record high or record low, right, and 0 otherwise. This is the indicator random variable, right? We are counting the number of years. All of you understood this small strategy, guys? This strategy is super important. When you're trying to count something out of a given set of random variables, what you have to use is that you have to use the indicator random variable, because indicator random variable is just like you're counting step by step, a success or a failure. Okay? So it's a success or a failure counting. Do you understand this strategy, guys? All of you. Do you understand this problem solving strategy? This is a very super important strategy. Nikhil has used this in the last problem. All of you understood this? Say yes or no. Now we'll change this to a problem. We'll change this to a problem. The problem statement. So how will we do this? So we'll change the problem statement. What we are counting? We are counting what? We are counting first step. We are counting what? We are counting the number of ij counts what? Ij is what? Ij counts the event will happen in one trial or now. So what will sum of ij count? The n is the number of years with record low and record high. ठीक है. So it's an exercise just below like classwork. It can be the sum of all the indicator random variables j from 1 to 100. So we are counting. So each gives what? If it's 1, it gives that it is a record high or a record low. If it's 0, it gives that it's not a record high or not a record low. So if we sum of all of this, we'll get all those ones जिसमें record high or record low है. So that means this is what? This is the sum of the number of years with record high or record low. All of you understood this strategy, guys? All of you understood this? This is a very important, super important strategy. Did you understand this? It's very important. Okay? Thank you, Abhiru. So now, N, Ij follows what? Ij follows Bernoulli sum P, which we don't know. We will calculate. We don't know. Okay. So what we got to find? We got to find expectation of N, right? The expectation of number of years with a record low or record high. So what is that? That is summation of expectation of Ij by the linearity of expectation j from 1 to 100. Right? This is the basic idea. And what do we get over here? So therefore it's equal to summation of j from 1 to 100 pj, because expression indicator is pj, where pj is what? Pj is what? This pj is what? Pj calculates the probability that xj is record high or record low. All of you understood till this point of time, guys? Is it crystal clear to you, the mathematical steps? It's super important. Is it crystal clear to you, the mathematical steps? Thank you. What about others? Is it crystal clear? Thank you. Perfect. Pratik, I hope you understand. Nikhil, I hope you're understanding. I'm not getting so much interaction from your end. Okay, so perfect. So therefore, to understand, to calculate this, we need to calculate what? We need to calculate P of j. That is probability xj is record high or record low. I understand both cannot happen together, so they are disjoint events. So what we can write using the laws of axioms of probability? We can write that its probability xj is record high, they're disjoint, so plus xj is record low. They cannot happen together, right? All of you understood the steps, guys? It's very easy. All of you understood the steps? The step, okay, it's very easy. I mean, there's nothing. So we will calculate just one of them. The other will be a reflection, like just same as other, okay? Because the IID. So what does it mean? xj is record high. That means xj is greater than all others. x1, x dot, xj minus 1. And this means what? Plus probability xj less than x1, x dot, xj minus 1. Okay? So let's understand this. How will you do it? So understand that we have done this last day. That xj greater than x1, x dot, xj minus 1 is same as probability xj minus 1 greater than rest of the stuff is equal to probability xj minus 2 greater than, because they're all IID, guys. This is the main idea. They're all IID. It's a symmetry. x1 greater than all of them. And sum of all of them, they form an exhaustive set. Exhaustive. So each one of them is equal, and therefore the sum is 1. So each one of them, there are j such options, so each one of them is 1 by j. Similarly for a minimum, each one of them is 1 by j. So do you understand? It's 2 by j. Did you understand? 1 by j for this and 1 by j for this. What we're using? We're using the famous principle, the super important principle, that is a symmetry of IID random variables. It's super beautiful, super easy, and super, like, what should I say? Super easy, super beautiful. All of you understood this. Did you understand this or not? Did you understand this? Is it a boom? Please write boom if you understand and liked it. Thank you. So this is the idea. Okay? We have done this before. We have done this last day. Pratik, did you understand? Or do you want me to explain again because you were not there in the last day? Do you want me to explain again, Pratik? Sure. So yeah, so you should tell me if you don't understand something. I would love to explain it to you. Let's say, let's take this. So x1 extra IID, okay? And also after this class, you must revisit the previous class recording to understand what we have done, okay? But I will explain you in short. So x1 greater than xj. See, if there are two random variables, either this will happen or this will happen, right? And understand that x1 and extra IID. So it's like renaming of each other. Okay. It's like this. Probability. It's like you have two boxes closed. Okay. And it's like telling that probability, the right hand box has more money than the left hand box. Is same as the probability the left hand side has more money than right hand side. They're equal, no? They're absolutely, because they're IID. You understand? Do you understand this? So similarly, for more than one random variable, one of them will be the maximum. So x1, let's say x1, x2, x3 here. So either this will happen, one of them will be the maximum, either x2 will be the maximum or x3 will be the maximum, right? Any one of them will happen, and each are equal probability. Either one of them will be maximum, each will equal probability. Why? Because the IID, because it's just a renaming of the entire thing. And each one of them are equal, and each one of them, like adding up all of them, like forms the entire space, right? Because one of them must be a, like, in a set of numbers, in a set of random variables, one random variable must be the maximum. So they are exhaustive. Did you understand, Pratik? Yeah? Good. So sum of them is 1, and each one of them are equal. So there are j of them. So each one of them is 1 by j. So that is 2 by j. But that is not complete. We need to find out expectation of n. So what we need to do? We need to find out which is equal to summation of Therefore, it's what? It's summation of j from 1 to 100, 2 by j. You can understand it from here. You know the famous result that it's a harmonic series and it diverges. So therefore, the number of years with a record low or record high, okay, is really exponent number of years is really high. You understand? Good. Perfect. So in that case, in the first year, it's always 1. See? Or maybe just doing some mistake. Thanks for the question. I think for the first year, yeah, it's yeah, you're right. Yeah, thank you for this. 1 plus that. So what is the problem in this? In that first case, as he told the problem is this, that x1, like x1 is a record high, it's always 1. So it's 1, like x1 is always a record high or the record low, always, because there's only one random variable. So therefore it's 1. Yeah, thank you for this. So it's 1 plus, yeah, you're right. So you understood where I made a mistake and Nikhil corrected me? All of you understood that? Thank you, Nikhil, for this beautiful point. That's a very important point. Did you understand, guys? Please say a boom for Nikhil for his beautiful thoughts. Because what we are doing summation of ij, right? We are doing summation of ij, but there is no difference of record low, record high, or record low in the first j is equal to 1 case. So pj is always 1 over there. Out of one number, it is always record high or record low, right? You understood, Polomi? Out of one number, that number is always record high or record low. There is no comparison to make. So I of 1 is only 1, always. It's vacuously true. Yeah. Did you understand, others? Do encourage your like classmates, guys. Say a boom for Nikhil. Very good, lovely. Okay, so coming back to the problem, it's 1 plus j starting from, yeah, nice approach, nice. Actually, I got this, like, nice. Thanks for correcting the mistake. And it's, in fact, these are the places where students get baffled. Okay, so now the next question. This is done. The next part. On average, in how many years in 22nd century is there a record low followed in the next year by a record high? You understand? It's a very interesting problem. So what do it mean? Let's understand this. So here also same indicator random variable we will be doing. So it's indicator random variable means that I of GMA, it means that it's 1, we are counting it. What we are counting? That xj, what is the idea? It's told that it's record high followed by a record low followed by a record high. So xj is record low and xj plus 1 is record high. Zero otherwise. So this is the problem. Did you understand what we are counting? We are counting those cases where xj is record low and xj plus 1 is record high. That's what it's counting, right? And that's why we have made this random variable. That's why we have made this indicator variable, because the question revolves on the fact that find the number of years. In how many years? That means on average, in the expectation of number of years in the 22nd century, such that there is a record low followed by a record high next year. Okay? All of you understood this definition of indicator random variable, why we define like that? Any doubts? Did you understand it? Say yes or no. Any doubts? What about others? Did you understand or not? See? Polomi, Pratiksha, Mansi, Proma, Shuprabha, are you not understanding? Okay, sure. Thank you. Okay, so we are counting this. Similarly, we need to find exactly expectation of ij, summation of ij, in fact. So, as you can understand, the only important aspect that will turn out is j, because you will get summation of that. The only important thing you'll get is P of j, it's summation of that. But the most interesting thing we have observed that there are infinite number of years where you will get a record low or record high. Isn't that really astonishing? I mean, if you count from the Jesus Christ time, AD 1, it'll be infinite amount of time. It's harmonic, it's really increasing fast in rate of log n, that it's going to like observe a record low or a record high. So it's really something really interesting, intriguing. And this is something like record low and then record high. It's like rainfall, let's say. I mean, after a drought, you will you will get a really very good monsoon for the farmers. Okay, so this can be a good way of understanding it. So that's why counting. So you can understand that n is equal to summation of j from 1 to 99, right? I of j, and expectation of n will be equal to summation of j from 1 to 99 P of j. We are doing this really fast because we have done this before. So we are only interested in finding therefore P of j. That is what will really matter. Okay, that's the idea. Okay, and therefore we'll find that. Let's try to find that idea. What is P of j? Okay. Okay, so whenever you're doing a problem, not only just do the problem, also understand the implications of the problem with the real life. It will make your understanding much more beautiful and with much more clarity. Okay, so 1 if xj is record low and xj plus 1 is record high. So pj, find pj. So we need to find probability that xj is record low and xj plus 1 is record high. So let's write down the mathematics of this. Mathematical format of this, we will find probability no, j is from 1 actually. So j is from 1 to I've if it would have been from 2 if it was j minus 1. Okay, so since I've taken j plus 1, I've taken 1 to 99. If it was j minus 1 j, I would have taken 2 to 100. You understand? Sriteja. Okay, so this is a mathematical format that xj x1, like xj is record low That means xj less than x1, x2, that are xj minus 1. And all of them are greater than. No, there is no extra value. It's a double stuff. See, you need to understand there are two things. X1 will be record high and x2 will be record low. Sorry, xj x1 is record low and x2 is record high. So in that case, probability x1 will always record low is less than x2, which will be half. Okay, so check whether the final solution comes out to be half or not. Okay, for j, and then you put j is equal to 1. For j is equal to 1, you get this. Did you understand probleming? Huh? No, there is no okay. Yes, there is only yes or no. There is no okay. Did you understand? Yes or no? Okay, thank you. Perfect. So xj is less than. So this is record low of xj, and this is the record high of xj plus 1. Also understood that this can be written like this, right? This is the most important part, and the next important part is coming. Did you understand this? It's the expression the pj can be written like this. Did you understand this, guys? All of you, did you understand this? Yes or no? Okay. So this will be finite. Any intuitions? This will go to infinite or this will be finite? Bolo. Infinite. Okay, let's check it out. Infinite. Nikhil, any intuitions why infinite? You're doing it algebraically, but I'm just asking you like intuitively. Okay, let's do it algebraically only. So how to do this? Xj between the set of numbers j minus 1 numbers less than xj plus 1. So j and j minus j plus 1 are not. So we can do it like this. X1, any xk and xm and x, any xm and any xn will do, right? Any xm and any xn will do, right? So how many such options are there that will somehow like that will like do the entire space? Any xm, one will be maximum, one will be minimum. We'll select those m and n, and that can be chosen in. That can be chosen in how many ways? How many numbers are there? J plus 1 numbers are there. So j plus 1 choose two ways, right? The highest and the minimum and the maximum chosen in j plus 1 choose two ways because the j plus 1 numbers for pj. So therefore it's what? If you sum all of them, that all of them are equal, and if you sum all of them, like if you add all of them, if you take union of all of them, that will be the entire space. So pj will be 1 by j plus 1 choose 2. Did you understand, guys? Did you understand this? All of you understood this? No, we don't choose any two consecutive. XJ IID over here. xi is the IIT over here. We don't care, like here the condition is this. J is fixed. And each combination equally likely is right. Each combination is equally likely. Let's take an example. Like there will be one maximum and one minimum. In this case, out of let's say j is equal to 10 and j plus 1 is equal to 11. So they are telling that x10 is the minimum and x11 is the maximum. Right? This is what it means. If this happens, a maximum and minimum can be chosen in, it can be any maximum minimum since the IID x1 and x9, x2 and x7, x3 and x10, kuch bhi. And this is one such possibility. And how many such possibilities are all equally likely case because of the IID symmetry nature? Is j plus 1 choose to 11 choose to, right? 11 choose to numbers. So 11 choose to ways of picking one maximum and one minimum. And all of them are equally likely, all of them are exhaustive. So therefore 1 by 11 choose to. Did you understand this, guys? Say yes or no. Say a boom if you understood this. Did you understand, all of you? Boom. Perfect. All boom. Superb. Okay. Let's now. Thank you. Let's now see whether it's a convergent or divergent series. So therefore, PJ is this. So Nikhil, it is a convergent or divergent? What do you think? Now, so we get expectation of n over here will be what? It will be summation of 1 by j plus 1 choose 2. J from 1 to 99. But let's check, like let's see whether this summation is divergent. This series is divergent or not. What do you think, Nikhil? Divergent or not? Okay, so if you put j is equal to 1, isn't it coming out to be half? It's coming out to be 1. Yeah, it's coming out to be 1. कुछ तो, yeah, I missed that. Yeah, yeah, actually I thought about that, but I'm just thinking like, but shouldn't it be? Now, why the last case? I don't understand. Last case is totally fine. I'm not also sure about this case. Why it's happening like this? J plus 1, j is equal to 1. Why it's happening like this? So when we are doing j choose, like okay, j is equal to 1, so we get this, right? So one maximum and one minimum. So we choose the two. Okay. Okay, I did a small mistake. Did I do a small mistake? Yes. This is the j plus 1 choose 2. Because j plus 1 choose 2 is not true. Thank you. So it's x1 and x2 is not same as x2 and x1. So it will be j plus 1. It will be j plus 1. Bolo, bolo, bolo. It will be j plus 1. It will be j plus 1. P2. Perfect. P2. Then it will be. So therefore it's 1 plus 1 by j plus 1 P2. Thank you. J plus 1 P2. So now tell me whether this will be yeah. So now put j is equal to 1, you get 2 factorial by 0 factorial, that is 2. So it's half. You understood? Now this is not a bad case. All of understood that a p is equal j is equal to 1 gets also satisfied over here. In fact, did I do anything wrong over here that j is equal to 1 step was not satisfied? Yeah, actually, in that case, actually both the, I mean, in that case, record high and record low was actually same. So that's fine. But here it's not same. Here it's like here is distinct. Did you understand this, guys? All of you understood this? Nikhil, is it clear? Nikhil, is it clear? Pratik, is it clear? All of you, it's clear, or will I repeat? Abhirup, Mansi, Mayur, Paulami, Pratik, Pratiksha, Proma, Sriteja, Shuprabho. Is it clear or not? Guys online, is it clear? Yeah, you're right, Shantanu. Thank you. It will be 1 plus j plus 1 p2. You're right. Thank you. Clear, all of you clear? Good. So it's j plus 1 p2, not choose 2. Perfect. So, lovely. So now tell me, it will be a finite or infinite? This one is infinite or infinite? Tell me. In fact, it's easier to find it now. Summation of j from 1 to n, 1 by j plus 1 into j. Can you do this? So there is something called telescopic sum. 1 by j minus j plus 1. Right? So it's like this. 1 minus half plus half minus 1/3 plus I say. So it's 1 by n minus 1 by n plus 1. So all this will get cancelled. So it will be 1 minus 1 by n plus 1. So limit n tends to infinity क्या होगा? Limit n tends to infinity क्या होगा? It will be like, it's not choose 2, it's p2. We have made the change. 1. So isn't it beautiful that the expected number of time this will only happen is 1. After record, after drought, you will be getting a really heavy rainfall in your village. That will be like expected number of time that will happen is 1. Isn't it really beautiful? Isn't it really beautiful? Yep. So this is the problem, and so I have a question to you. Do you want to do the third part, or do you want to do a new problem? Do you want to do the third part, or do you want to do a new problem? Bolo, do you want to try out the problem at your home for the third part? Or do you want a new problem? Yeah. What do you want? कुछ तो बोलो. New problem. Okay. So try out. Take a screenshot of this problem and try it out. Okay. N be the number of years to get a new record high. What is the new record high? That is X 2101 is the record high. So the new record high, you can easily understand that. Okay. So find out. It's really easy. Okay. So now let's try out some past year IIT JAM problems on the same aspect, same ground. Yeah, it was my idea. 1 to 99. It was in fact, I mean, my idea was to make like that's why you like n large is given, okay, so that you get an idea about the number. So since I know what is going on in my author's mind, that's why I told like he has asked to calculate like what will happen in 100 years. So, but my aim is like, I mean, it's if you take small number of years, you will get less than one. Okay, but if you get in industry infinite, you will see the bigger picture, what's really happening. So that's why I just made it. Also, I wanted to like shun your real analysis knowledge. Okay, which is not the idea of the author, because you have it in your exam. So that's why I am doing it. Okay, did you not like it? Follow me. Oh yes, I don't like it, no. Okay, I'm just joking with you. Okay, perfect. So yes, thank you for giving the problem. Okay, let's move on to the next problem. It's a past year IIT JAM problem. Just give me a minute. I will just take a screenshot of the problems. Let's do something interesting. Um, so let's do this problem. It's a very IIT JAM problems are not so involved. Like we can do it in really using your hand. Like you can close like this for the past years. Okay, not the past 2 years. So let's do this problem. It's a really easy problem, and it's asking that for which value of k is a PDF. So what you have to check, guys? What are the conditions you have to check for a PDF? What are the conditions you have to check for a PDF? MK Jan, you can do the path. I have given the path as the homework. Path as the homework. Okay. So how to approach this problem, guys? Area is under. There is no area. Okay. I mean, what are the conditions? Two conditions for PDF. Bolo, this should be at the tip of your lips. Non-negative and non-negative and continuous. Continuous, Riteja. No, wait a minute. Sritija, wait a minute. Do we need a PDF to be continuous, Sritija? Do we need PDF to be continuous? Don't make these mistakes. Do we need PDF to be continuous, Sritija? No, can you give me an example? I have done this example in class. Right continuous. So this is it's a PDF, not a CDF. Don't confuse. Yeah, you're right, Nikhil. But I'm just trying to understand, like, what is the I don't understand. Like, we have taught probability for such a long time, and you're not able to answer this. It's a really like this is making me sad. So tell me, what are the like do PDF need to be right continuous or left continuous or infinitely continuous? Tell me, Sriteja. Please unmute yourself. Can you please unmute yourself, Sriteja? Okay. So tell me, like, give an example. Do you understand PDF and CDF was not same? So what is the continuous random variable? What is the definition of continuous random variable, Sriteja? I've done it a lot of times. This is what I've taught you, Sriteja. This is what I've taught. What is the continuous random variable, guys? Like you attend classes, right, Sriteja? So I have taught that a continuous random variable is takes values in a range. Yeah, I have taught this. Others, what is the continuous random variable? Follow me, what is the continuous random variable? Yes, CDF has to be continuous. So who doesn't know that continuous random variable definition is CDF has to be continuous? I told it so many times in 2 consecutive classes. Why don't you remember this? Like, I don't know, like, Sritaja, please answer me. This is really not a happy moment for a teacher. Like, if you're confused, then ask me. Why don't you ask doubts? We have given one-to-one doubters, WhatsApp. We have given all the facilities you have asked for. And now, after this, if you tell that you are confused, this is not acceptable, right? That means you are doing something like you are being not serious about your studies. This is not done. Please go to the videos. Okay, who doesn't know the definition of continuous random variable? Who doesn't know the definition of continuous random variable? Huh? Yeah, please do this. Otherwise, I mean, you guys are working so hard. If your basics are, we are doing in so much details in so much basics. If you can't answer this simple certain aspects of the whole thing, like, then what's the point of teaching with so much passion, guys? I can give you just like the notes of other academies, and you can learn it yourself. Then what's my way of doing it? What's our way of doing it? So in so much details and with passion. If you don't like whatever, what should I say? Anyways, so do you guys know that CDF has to be continuous? Like the definition of continuous random variable is that the fx has to be the CDF, like the CDF has to be the continuous. Do you know this? All of you know this, yes or no? Yes. Good. Pratik, do you know this? Mayu, do you know this? Proma, do you know this? Okay. So, does PDF need to be do we need PDF to be continuous? What do you think? Do we need PDF to be continuous? If not, if yes, tell me why. If not, give me a proof. Do we need PDF to be continuous? Do we need PDF to be continuous? Tell me. No, give me an example. Why no? Give me an example. Yeah. No, wait. Abhirup, you are telling that PDF has to be continuous. Okay, why do you think so? What is a PDF? What is the definition of a PDF, Polo? Now this is getting really interesting. What is the definition of a PDF, Abhirup? Please unmute yourself and talk to me. What is the definition of PDF? Please unmute yourself, Abhirup. Don't tell that you have mic issues. What is the definition of a PDF? Probability density function. all the हाँ बोलो बोलो बोलो. Okay, so always the CDF has to be differentiable. No, you told that PDF is the derivative of CDF, and also PDF CDF is not differentiable. Okay, okay, so can you just tell me, like, let's take uniform random uniform PDF. Okay, I mean, what did I define the PDF in the class? Do you remember? Do you do the class? Did you do the class? Let's ask Sriteja. Sriteja, what is the definition of PDF? I took entirely 1.5 hours plus another 45 minutes to explain the entire concept to you, and now you telling me wrong things. I discussed each and every problem, like we discussed whether a PDF need to be continuous or not. You need to attend classes, guys. So bolo Abhirup, please unmute yourself. Okay, so like what is the definition of PDF given in the class? Wait, okay. PDF describes, so what is the definition of PDF for a random variable? So what is the definition of a CDF of a random variable? Yeah? What is the definition of a CDF? बोलो बोलो. You can look it on the internet. I have no issues. But I will ask you questions that you will not find the internet. Okay. So Nikhil has told probability that a random variable takes values less than equal to x. So that is, do you think it's a CDF? This is the definition of a CDF, or we do? So what is the definition of a CDF of a random variable? That's my question. So your friends have answered something. Nikhil has answered something. Do you think that's the definition of a PDF? Yeah? Bolo? Did you watch the lectures, Abhirup? Say yes or no. Why? Do you think that like what we teach can be like if something can be skipped, we will not teach it? Yeah, I mean, see, I mean, see, it's like this. You are paying me money. I'm getting paid for teaching, and you're not taking to the full advantage of it. You're only losing it out, and I'm feeling bad that like I'm feeling extremely bad. But that's like you like students may not care for it. But the thing is that you're losing out on the opportunity to learn if you skip videos like this. They may be theoretical enough, but that the theory is important so that I can ask you like these questions can come in mock tests. Like they will be giving four options that PDF can be continuous, PDF can be. They will like totally ask it. I know like I know them. So what will you do then? Yet asking for problem solving classes and you don't know the theory. So how will it happen? Like how does it merge together? You don't know that whether a PDF has like what is the definition of PDF and you want to solve problems on PDF. That doesn't work that way, no? Life is not so easy. No, something else. That's not the definition of PDF. See, I will tell you something. At this point of time, if you're not serious, please be serious, okay? I don't know, I want to demotivate you, plus please be serious at this point if you have serious goals, okay? Devote some time to seeing the videos. Okay, if something can be skipped, we could have skipped that. We wouldn't have taught that. Please don't skip videos, okay? Make it strong. And I'm telling to each one of you. And I will ask questions, I will understand totally the condition of the whole thing. So Nikhil, please unmute yourself. I want to know what is the definition of PDF that you know and CDF that you know. Since you're a new student, I want to know your knowledge base. Hi Nikhil, can you unmute yourself? Please tell me what is a CDF. Okay, good. So this is the definition of CDF. Perfect. So what is the definition of a continuous random variable? Okay, so where did you learn this definition from? Okay, so who thinks that this is the definition? Okay, what is the definition you know, Mansi and Pratik? Bolo. Mansi, what is the definition of CDF? Sorry, what is the definition of continuous random variable? Okay, so what is the definition of a PDF? Height? Height what? Did you see the lectures? Okay, did I mention height? What is the mathematics behind it? See, intuition is really good. You know, the difference between intuition and mathematics is like writing a poem and thinking of a poem. It's like sitting outside, sitting in a monsoon season and thinking about how beautiful the rain is, and it's like the intuition, and the mathematics is like the author who is writing the like poem about the monsoon. So you have to know, you have to be the author. So Apollo, what is the definition of a PDF? Okay. Yeah, I didn't get you. This is not what I defined in class. Okay, I have another question. Can a discrete random variable have a PDF? Certain basic questions I'm asking. Can a discrete random variable have a PDF? No, no, no. First define a PDF. No, no, no. First define a PDF. So that's why you don't even know the mathematical definition of PDF. How will you answer this question that whether discrete random variable is a PDF or not? That's why definitions are important. Like if in IIT this question, basic question comes without any problems, like if the CDF must be differentiable, the PDF must be continuous. The PDF exists for discrete random variables, and PDF is differentiable. How many of these are true or false? You will be in total blue. Like you will not know anything. You will not like you. This is the most easiest question. This will be the most easiest question on the question paper, and you will not be able to do it. This is not the definition of PDF. What is the definition of PDF? So all of you told the definition of CDF. What's the definition of PDF? See, I am scolding you. I am a bit harsh and rude today just because of one thing that I am teaching you probability for this long time for many of you, and we focus 60 to 70% of our time to probability just because probability is the really most basic and the most most important and most badly taught subject in the entire country. And exactly that's why your statistics basic is weak. That's why we give so much importance to probability. So you must learn the subject without thinking about it too much. Like if I ask you about a PDF, you're telling it's like height. Height of what? What is the height? See, if I ask you whether PDF is there for continuous or discrete, you don't know even whether it's continuous or discrete. Like, what is the use of this knowledge then? So PDF is defined for continuous random variables only. So this is the transition of the whole idea. First, we read about discrete random variables. Okay? And from there, we learn CDF. CDF is what? It's a function based on the. Okay, let me ask you a really basic question. Mansi, what is a random variable? Okay, perfect. So this is a random variable. So random variable, we are defining f of x to be x, which takes values in this. That is probability of this interval. Now we have done this property that the jump, like the fx is right continuous, we know that, but the left, why it's not left continuous? Because limit h tends to 0 minus f of x minus f of xh, like it's coming from left hand side, it's actually equal to what? It's actually probability x is equal to x. This is a jump. and therefore this, since for discrete random variable this is not equal to 0, that's why there is a jump for discrete random variables. So using this intuition, we told that okay, what if fx is continuous? X is, we therefore define that x, what is continuous in continuous random variables? We told that the continuous in the continuous random variable is if the CDF is continuous. Will you ever forget that? What is the definition of continuous random variable, guys? Will you forget this? All of you write down the definition of continuous random variable in the comment. Otherwise, I will not proceed. All of you write down. Write down the definition of continuous random variable in the comments. No, that is not the PDF, Shantanu. Please write down the definition of continuous random variable in the comments. Now. I will give you 1 minute. I have to scold you and teach you just like I have to teach a school children. If you do a mistake, I have to make you write down so that you remember that. Are you writing down, guys? Good. Good. Please write down. Please write. All of you, please write down. Don't copy and paste others' answer. Good. All of you wrote it down? Abhirup, did you write it down? I wrote the definition, still you are not being able to write the definition properly. X is continuous if its CDF is continuous. A continuous animal is a random variable with a continuous distribution function. Okay, fine, good. So now about the PDF. Where does PDF come from? I made a mistake initially in the first day. I corrected it in the next day. Is that a continuous random variable is said to have a PDF fx if fx is greater than equal to 0. Integration fx must be integrable. Riemann integrable function. It can be integrated. Any function, a discontinuous function can be integrated. Okay. Fx is integrable. 0th point is fx is integrable. An integration of fx minus infinity to infinity dx is 1, and capital of fx is equal to integration of this fx ft dt. If note this very carefully, if this the density that the CDF is differentiable, then integration of minus infinity, then f dash of x is equal to small f of x, and small f of x is continuous. So it is an example of a function of a PDF that is not continuous. It's uniform distribution, 0, 1, that Ptolemy told. And uska CDF looks like this. It's continuous. Its PDF can be discontinuous, but its CDF is continuous. So every integration of every integrable function is always continuous. Did you understand this? Will you ever forget it, guys? So will you ever forget it? So Abhinav, what is the definition of a PDF now? Bolo. Unmute yourself. So don't say height and that. That is for encryption. No, as I told that PDF exists for only PDF is defined for continuous. So as I told, PDF is defined for continuous and available because I understand that PDF must be integrable. Fx must be integrable, and any integration of integrable function is always continuous. So therefore, the density is the CDF is continuous, and therefore it must be a continuous random variable. So PDF and PDF is defined for continuous random variable. Okay, don't ever forget the simple stuff, guys. This is very basic. Abhinav, did you understand? Sweetaja, did you understand? Nikhil, did you understand? Will you forget this? Don't forget this stuff, guys. This is super important. Mansi, did you understand? And go through the videos, please. We work so hard to teach you. And if you don't respect that, then who will respect that, Bolo? Okay? So all the best. Like I don't really want my students to be not knowing this basic stuff. They can be weak in problem solving, but the theory should be really strong, super strong, so that no one can pick and poke into that. I mean, there should be a difference between Cheenta students and other students, right? Otherwise, why the existence of Cheenta? Will you forget this, guys? Say no, all of you. Good. I want no from all over, all of you. Remember that Cheenta students have to be different, and they are different. Okay. Good. Okay, so let's do this problem. So I just asked you this because I wanted you to ask whether PDF need to be continuous and whether it's a PDF or not. So we have to check whether it's a PDF or not. For the PDF, it's integrable function. So mod x is integrable. So function of mod x is also integrable. So it's a continuous function. So it's integrable. Zeroth condition done. It's non-negative. It's greater than or equal to 0. So k must be greater than or equal to 0. It's non-negative. Okay. So the only condition that is left is integration minus infinity to infinity k mod x by 1 plus mod x whole to the power 4 dx is 1. We have to find that k. It's essentially an integration problem. So you understand it's a symmetric distribution. Mod x is an even function. So we can write it as twice k of 0 to infinity mod x by 1 plus mod x whole to the power 4 dx. Now you can understand for x greater than 0, mod x is x. So you can write it as 2k integration x by 1 plus x to the power 4 dx, 0 to infinity. And you can find it out by integration now. And you can find out some value lambda, and you can find k from there. It's a very integration problem, okay? But the main idea was this even function idea. It's a very easy problem, guys. Okay, perfect. Thank you so much, and please be a different student. Please be unique and make your theory very strong. Okay, just don't only go for problem solving strategies. Your theory is, if it's weak, you cannot do even problems, small problems. How can you expect to do bigger problems? Okay, all the best and be a Cheenta student, guys. You should be different than others. Okay, bye bye, good night, all of you, and all the best.